Hello everyone, this is Shekhar, mechanical engineering graduate from IIT Delhi, having more than 12 years of teaching experience, out of which around 3 to 4 years is into JEE and NEET domain. So today I am going to talk about a very important and interesting concept in fluid dynamics, that is the Bernoulli equation. So fluid dynamics is also called as hydrodynamics, which is flow plus forces. So fluid dynamics is the study of the flowing fluid considering the forces causing the motion. So major forces which are acting on the flowing fluid are: one is the pressure force, which is pressure into area, and it is acting normal and compressive. The another force is gravity force, which is also called as weight of the fluid, that is mg, which is always acting in downward direction. So we are going to talk about these two forces on the flowing fluid. So what is Bernoulli equation? It is nothing but the energy conservation equation for an ideal flow. So what does that mean? For an ideal flow, the total mechanical energy or the hydraulic energy of the fluid always remains constant. So the energy associated with flowing fluid consists of: one is the pressure energy, which is pressure into volume. Another one is the potential energy, which is mgh, and the third energy is kinetic energy, which is half into m into v square. So the sum of these three energy for an ideal fluid, that is the total energy, always remains constant. All right. So let us talk about the ideal flow, because Bernoulli equation is applicable only to the ideal fluid or ideal flow. Ideal fluid or the ideal flow is the one which is steady. What does that mean? The velocity of the fluid should not change with time at any particular section. The second condition is the flow must be incompressible. It means density of the fluid remains constant everywhere. The third one is non-viscous, or we can also call it as frictionless flow. There should not be any fluid friction, or there should not be any type of energy loss. Because of the friction, there is energy loss. So the flow must be non-viscous. So let us take an example where there is a pipe in which the fluid is flowing from section 1 to section 2. The pressure at point 1 is P1, that is the inlet point, and the pressure at point 2 is P2, velocity at point 1 is V1, and velocity is at 2 is V2, and area at 1 is A1, and area, cross-sectional area at 2 is A2, that is the outlet point. And from any horizontal reference, the height of point 1 is h1 and the height of point 2 is h2. So first of all, let us talk about the mass conservation equation. If we apply the mass conservation, which is also called as continuity equation, and according to continuity equation, the mass entering should be equal to mass leaving from the pipe. That remains constant, we can call it as m. So in time dt or in time delta t, I can say mass is equal to density into volume. So we can call it as density into volume is area into delta x, displacement. Area into distance is volume. or delta x displacement is equal to velocity into time. So we can write it as rho into A into V into delta t. That should remain constant. That is our continuity equation. And because we already know that for incompressible fluid density remains constant, and that, so we can say area into velocity should remain constant. Delta t is also constant. So area into velocity remains constant. We can say A1 V1 should be equal to A2 V2. That is the continuity equation. Now, if we apply the work energy theorem, what is work energy theorem? According to work energy theorem, net work done is equal to change in kinetic energy of the fluid. This is H1, this is H2, this is area A1, this is area A2, right? So net work done is due to pressure force plus work done by the gravity force or the weight is equal to change in kinetic energy of the fluid. What is the work done by the pressure force? We can say P1 is acting, pressure always acts normal to the surface and it is compressive. So P1 is acting in the flow direction, but P2 is acting, or pressure force at point 2 is acting in direction opposite to the flow, that is P2A2. So we can say pressure force P1A1 into delta x displacement is minus P2A2 into delta x, isn't it? Plus work done by the gravity force always act in downward direction, and the fluid is rising up to a height h2 from h1 to h2, so we can say it will be negative work done minus m into g, and the vertical distance is h2 minus h1. Why there is a negative work done? Because the force is acting in downward direction and the fluid is rising in upward direction, is equal to half m. Final velocity is v2 and initial velocity is v1, right? So we can write it as p1a1 into v1 delta t minus p2a2 into v2 delta t minus m, that is equal to rho into a into v into delta t, isn't it? Into g into h2 minus h1 is equal to half rho av delta t, that is the mass density into volume into v2 square minus v1 square. So if we analyze this expression, a1 v1 delta t is equal to a2 v2 delta t is equal to av delta t is equal to av delta t. Everywhere av delta t is present. So our expression will be p1 minus p2 minus rho g h2 plus rho g h1 is equal to rho v2 square by 2 minus rho v1 square by 2. If we take the terms of point 1 on one side, left hand side, and the terms of point 2 on the right hand side, then our equation will become p1 plus rho g h1 plus rho v1 square by 2 is equal to p2 plus rho g h2 plus rho v2 square by 2. Or we can say, which implies that p plus rho g h plus rho v square by 2 should remain constant between any 2 points taken in the pipe. So this is the Bernoulli equation. So first term represents the pressure energy, second term represents the potential energy, and the third term represents the kinetic energy. But pressure energy, as I told you, is pressure per unit. Pressure energy is pressure into volume. So each and every term represents energy per unit volume, or this can be called as, this is the static pressure of the fluid. So the unit is energy per unit volume is Newton per meter square. Energy is Newton meter, volume is per meter cube. So each and every term is having the unit Pascal. So first term can be called as static pressure of the fluid. The second term is called as hydrostatic pressure of the fluid, which we study in hydrostatics. And the third term is called as dynamic pressure of the fluid. The pressure developed due to the velocity of the fluid is called as dynamic pressure, and these sum of these three terms always remains constant. If we divide this equation by rho, entire equation, rho is a constant parameter because the fluid is incompressible, so we will get P by rho plus GH, P by rho plus GH plus V square by 2 remains constant. Here each and every term represents energy per unit mass, that is joule per kg. And if we divide the entire equation by H also, G also, so the equation will become P by rho G plus H plus V square by 2G is another constant. This is another form of Bernoulli equation. These are the form of Bernoulli equation. Here it is energy per unit weight of the fluid, mg, because mgh is potential energy, so mgh divided by mg is, so that is joule per newton, that is meter. So each and every term represents meter. So it is called as static pressure head. It is called as static pressure head. The second term is called as datum head or potential energy head, and the third term is called as kinetic energy head, or we can also call it as velocity head. This is called as Bernoulli equation, right? So if we take a horizontal pipe, let us say H1 and H2 are the height of point 1 and point 2 from any horizontal line. If the pipe is horizontal, let us say this is 1, this is 2. So we can say H1 will be equal to H2 in that case. So our equation can be modified as P1 plus rho V1 square by 2 is equal to P2 plus rho V2 square by 2. Isn't it? So if in the flow direction, if area is decreasing, the flow area A2 is less than A1. If area is decreasing, then velocity will increase according to mass conservation or according to continuity equation. Area into velocity remains constant. So velocity will increase. And if the kinetic energy is increased, then there is a decrease in pressure energy. Pressure will decrease. So we can say here, as A2 is, I am talking about this figure, A2 is less than A1. So we can say V2 should be greater than V1, or we can say P2 will be less than P1. That is how we can apply the Bernoulli equation. Thank you and take care.